In the second question, given that f defined as f maps r to r except 0 as f of x is equal to x cube minus 1 by x cube. Yes, your messages are visible and I have just adjusted the sound quality also. Okay, f of x is equal to f of 1 by here the question is given as to find out the f of x plus f of 1 by x. Okay, let's practice the answer. Yes, your messages are also visible, no problem. So here is we have to find, yes, f of x plus f of 1 by x, okay, is equal to 0. We have to show that. Let work for from left hand side, LHS. Let's find out the f of x plus f of 1 by x. Let us we know that f of x is equal to x cube minus 1 by x cube. Let put the values in the given function. Then we have to write f of x means here x cube minus 1 by x cube plus f of 1 by 3 means 1 by 3 x cube minus 1 by x here, 1 by x whole cube. Okay, yes. Now we have to calculate each and every answer. So let's go for x cube minus 1 by x cube plus 1 by x cube minus 1 by, that is in the denominator the fraction we can write it's a reciprocal. Okay, then directly we can write like this, x by 1 whole cube, which implies x cube minus 1 by x cube plus 1 by x cube minus x cube. While simplifying, we will cancel the x cube minus x cube and 1 by x cube minus and plus 1 by x cube. Finally we get as 0. So that's why we can write as f of x plus f of 1 by x is equal to 0. This is the answer for the second question. Let's move for the third question. Okay, let's move for the third question. What we have to find and what he have given. Okay, let's move for the third question. The third question given that f maps r to r, f maps r to r, and f defined as f of x is equal to 1 minus x square by 1 plus x square. Then find the f of tan theta is equal to cos 2 theta. We have to prove that f of tan theta is equal to cos 2 theta. Okay. Yes, there are some of them watching, but they are not having any groups. Okay, let's go for the answer. And f of x is here defined as, f of x is defined as 1 minus x square by 1 plus x square. Then find the f of tan theta. Then we can write as 1 minus tan theta square by 1 plus tan square theta. Okay. Then we can write as let's change the tan theta into sin theta by cos theta. Then we can write it 1 by sin square theta, 1 minus sin square theta by cos square theta whole by 1 plus sin square theta by cos square theta. Okay, while simplifying we will get as cos square theta minus sin square theta by cos square theta. Okay, whole by, we can write as another one, that is a cos square theta plus sin square theta by cos square theta. Okay, we can easily cancel the denominators cos square theta and cos square theta. Then we will get as a fraction as cos square theta minus sin square theta, okay, by cos square theta plus sin square theta. But we know that cos square theta plus sin square theta is equal to 1. We can write as cos square theta minus sin square theta by 1. Okay, let's go for the another point here. So we know that I justly extension this like as a cos theta into cos theta is equal to cos square theta minus sin theta into sin theta. Okay, we can write as directly cos 2 theta by way of sin cos a plus b is equal to cos a cos b minus sin a sin b. Then we can write as cos 2 theta. That is the answer. So f of tan theta is equal to cos 2 theta. It is RHS. Let's hence the proved. Okay, this is the answer for the third one. Let's move for the fourth one. Now we are moving the fourth question. Let's move for the fourth question. Okay. Yes, let's move for the fourth question. Fourth question is defined that f of x is equal to log 1 plus modulus of log 1 plus x by 1 minus x. Find the value. Okay. Okay guys, no problem, just watch it. Yes, if anyone interested. Let's go for the fourth one. Here f maps are except plus or minus 1 to r. F of x is defined as a log modulus of 1 plus x by 1 minus x, defined as, then find the f of 2x by 1 plus x square is equal to 2 of f of x. Okay, let's go for the answer. Okay, first of all we have to write the question. It is like this: f of x is equal to log of modulus of 1 plus x by 1 minus x. Okay, then f of 2x by 1 plus x square is equal to, we can write as log of 1 plus 2x by 1 plus x square whole by 1 minus, okay, we can write as 2x by 1 plus x square. Okay, then we can write as log of modulus of 1 plus x square plus 2x whole by 1 plus x square. Okay, then by, so 1 plus x square minus 2x whole by 1 plus x square. This is the modulus. Then we can easily cancel the 1 plus x square and 1 plus x square. Then we will get as log of, okay, 1 plus x square plus 2x whole by 1 plus x square minus 2x. Okay, then we can easily find, we can write as the polynomials in the square formula, like 1 plus x whole square by 1 minus x whole square. They are in the form of a plus b whole square and a minus b whole square. Then we can write as simply log of modulus of 1 plus x by 1 minus x whole square. Okay, according to the logarithm formula, we can write as directly 2 log modulus of 1 plus x by 1 minus x. Okay, this is the final test. And as our definition here in the question given that f of x is equal to log modulus of 1 plus x by 1 minus x, and then right now we can write this part as a f of x. Okay, then 2 into f of x. Here is the answer. It is the RHS. We have proved that f of 2x by 1 plus x square is equal to 2 of f of x. This is the answer for the fourth one. Okay, then the four questions are, we have answered that. And let's move for the fifth one. Okay, let's move for the fifth one. Okay, let's go for the textbook page. Okay, here is the textbook. Okay, here is the question given that it is one of the easy question. Then a is a, yes, okay, it is easy question, not to worry here. Okay, a is a set of -2, -1, 0, 1, 2, and f maps a to b, and is a given that as a surjection. He is given that surjection. Then f of x is equal to x square plus x plus 1. Then find the b. We have to find the b. Then first of all we have to find the f of -2 is equal to -2 whole square plus -2 plus 1. We can write as 4 minus 2 plus 1. We get 5 minus 2 is equal to 3. And we have to find the f of -1. It is -1 whole square minus 1 plus 1. so cancel, that will get 1, and we have to find the f of 0. So 0 square plus 0 plus 1, we will get as 1. And now we have to find the f of 1, that means 1 square plus 1 plus 1, that is equal to 3, and f of 2 we will get as 2 square, okay, 2 square plus 2 plus 1 we will get as 7. So finally we got B is a set of like, and 3 1 7 we have to write in the set form is only once, that's why we can write as a 3 1 7. This is the answer for the fifth question. Let's go for the sixth one. Okay, this is about the fifth one. Let's go for the sixth one. Yes, somebody asked in our group, try to answer and every question, that's why. Let's go for the sixth question. The sixth question, given that A is a set of 1 2 3 4 and f maps A to R, then find f of x as defined as x square minus x plus 1 by x plus 1, then find the range of f. Okay, let's find out the first of all f of 1. We have to find the f of 2 and f of 3 and f of 4. Hi Moses. So let's find out the f of 1. F of 1 means here 1 minus 1 minus 1 plus 1 by 1 plus 1. We can directly simplify, and then we will get as 1 by 2. And here 2, that means 2 square minus 2 plus 1 by 2 plus 1. We get as 4 minus 2 plus 1 by 3. We will get as okay, 3 by 3. Then we will get as 1. Okay, and next one is f of 3. That means 9 minus 3 plus 1 by 4. We will get as 9 6 7 by 4. Okay, and next one 4. That means 16 minus 4 plus 1 by 4 plus 1 means here 5. We will get as 13 by 5. Okay, this is the answers. Then we can write is the set as the range of the f of x is equal to 1 by 2, 1, 7 by 4 and 13 by 5. This is the answer for the sixth one. And let's go for the seventh one. Okay, let's go for the seventh one. These are the two most questions most important in the IP exam. Okay, so the Roman one, all questions are for the 2 marks questions. And let's go for the seventh one. And f of x plus y is equal to f of xy for every x comma y. Okay, then find the f is a yes. Okay, hi. So anyone doubt, please raise your voice and definitely I will give your answers. Okay, yes, it is a constant function. Then f is a constant function. Okay, we have to find that. So let f of x plus y is equal to f xy. Let's take x is equal to 0 and y is equal to 0. This is the condition 1. Then we can write as directly f of 0 plus 0 is equal to f of 0 into 0. Then we can write as 0. This is the condition 1. Let's take f of x is equal to 1 and y is equal to 0. Then we can write as f of 1 plus 0, that is equal to f of 0 into 1. Okay, that means here we can write as f of 1 is equal to f of 0. Okay, that is equal to 0. Okay, directly write, we can write as, or don't write as a 0, just leave it here. That is equal to, here we can write as f of 0, here also f of 0. Okay, now let's take as x is equal to 1 and y is equal to 1. Okay, let's go for f of 1 plus 1 is equal to f of 1 into 1. Then we can write as, which implies f of 2 is equal to f of 1. Okay, this is condition 1 and this is equation number 2. Let's take f x is equal to 2 and y is equal to 1. And then we can write as f of 2 plus 1 is equal to f of 2 into 1. Then we can write as f of 3 is equal to f of 2. This is from 4. From this is 3. From 1 and 2 and 3 we can write as f of 3 is equal to f of 2 is equal to f of 1 is equal to f of 0. F of 0. In this way we can write as for every value we will get as f of 0. Then finally we can write as f of n is equal to 0. F of 0. Okay, that's f is a constant function. Okay, this is for the question number yes, question number for this, yes, it is 7th one. Thus in the first exercise we complete the all 2 marks questions. Let's move for the 4 marks questions. Okay, let's move for the 4 marks questions. Okay, let's answer the 4 marks questions. The first question is given that, so here we are entering to the proofs, so we have to prepare well. How to prove the given function is a injection or surjection or bijection? We will start here. Let's go for the first question. First question defined as A is a set of x such that x is lies between -1 to +1. Okay, then f of x is equal to x square and g of x is equal to x cube, and then find which is the given functions are surjection functions. For first one, f maps a to a is a surjection, we have to prove, and g maps a to a surjection function. Here we have to prove which one is the surjection function. Okay, let us take first of all whether they are surjections or not. Okay, then we can write f maps a to a. Okay, then f of f value, that here x value is lies between -1 to +1, and f of x is equal to here x square. Then let's take y is equal to here we have to assume as a. Then we can write as f of x is equal to directly write y, which implies x square is equal to y, then x is equal to square root of y. Okay, here is the condition. Okay, here is the condition. Then let's take that y value as a -1. Then we can write as x is equal to square root of -1. But here the square root of -1 is not in the given range. Okay, that's we can finally conclude that f of x is not a surjection function. Okay, this is about the one. Let's go for the second one. Let's go for the second proof. Second, that ask that g maps a to a is a whether check the surjection or not. Let's take a is a set of x such that my x lies between -1 to +1, and g of x is equal to x cube. Okay, then we can write as here g maps a to a, then we can write as y belongs to a, then g of x is equal to y, then we can write as y is equal to x cube. Okay, then x is equal to cube root of y. Let us take y is equal to -1, then x is equal to, we can write as -1. Why? Because cube root is, we can easily find them. Then if y is equal to 0, we can write as x is equal to 0. If y is equal to 1, then x is equal to 1. These all are belongs to a. Yes, these are all belongs to a. Then we can write as g maps a to a is a surjection. Okay, it is a surjection function. Then in this way we can prove the first question. Okay, this is sometimes gives a for the 5-mark question. Okay, this is about the first question in the Roman 2. Let's go for the second one. Okay, let's go for the second one. Okay, yes, let's go for the second question. The second question given for internal questions are given. Yes, I will explain only same model. So I will explain in the 4 questions. In the, I think 6 questions are there. I will definitely explain for 3 questions, and you can practice remaining questions. Okay. Okay. One second, please. Yes. Yes, here is the question. Yes, here is the question that given that as show that given functions whether injection or surjection or bijection. We have to show them. We have to show them whether they are injection or surjection or bijection. Sangrastamu anvayamu dviginamu. Okay. So first of all, let's take the first question. How we have to prove that? So in earlier classes we have definition about the injection functions. How we have to prove that? So here f maps R2 are a function as defined as f of x is equal to 2x plus 1 by 3. So in the injection function we have the definition as f maps a to b, and x1 and x2 belongs to a, and f of x1 is equal to f of x2, then we can write as x1 is equal to x2. This is the proof to show that given that as a injection function. Okay, let's move for the answer. Let us take the f of x here is equal to 2x plus 1 by 3. Let's take f of x1 and is equal to f of x2. Whether they are equal or not, we have to prove that. That's very simple. It is a very unique way. You can easily answer them. We have to put the x1 and the x2 in the given function. That's all. So 2 of x1 plus 1 by 3 is equal to 2 of x2 plus 1 by 3. We can easily simplify both sides 3, and we can write as 2x1 plus 1 is equal to 2x2 plus 1. We can now also cancel the 1, and then we can write as 2x1 is equal to 2x2. Then we can easily cancel the coefficient also. Then we will get as x1 is equal to x2. Then f is a injection function. It's over. Injection function. Okay. Next, that means 1 function. That is other than 1 function. Okay, is simple. And next one, we have to prove that it is given as a surjection function or not. Okay, let's take as f of x is equal to y, which is equal to 2x plus 1 by 3. Then 2x plus 1 by 3 is equal to y, which implies 2x plus 1 is equal to 3y. Then 2x is equal to 3y minus 1. Then x is equal to 3y minus 1 by 2. Here we got x value. Okay, x is equal to we got as 3y minus 1 by 2. Now we have to find the f of x. And f of x is equal to, we know that 2x plus 1 by 3, we have to substitute the value here. Then we can get as f of x means here 2 of 3y minus 1 by 2 whole plus 1 by 3. We can simplify by them easily. 2 into 3y minus 2 plus 1 by 3. We will cancel like them, and we can write as a 3y minus 1 plus 1 by 3. By simpling, we will get as 3y by 3, then we will get as y. So finally we got as f of x is equal to y. So in this case we can write as f is a surjection function. Thus f is a injection function and also f is a surjection function. Thus we can write f is a bijection function. That's the proof. In this way we can prove. So there is a simple way. So we have to prove the one function. We have to take the x1 and x2, and finally we show that x1 is x2. And in the onto function, we have to consider as f of x is equal to y, and we have to find the x value regarding to the y, and finally we substitute the y value in the given function. Then we can show that it is a surjection. If we got both surjection and injection, we will directly prove that it is a bijection function. Okay, let's go for the another one. So in the question we are going to the second bit that is given here. So I have only Telugu medium textbook, that's why I give the Telugu medium textbook image here, and but I will explain everyone in every question in English, no problem. Okay, let's go for the second one. Okay, second he is given as, you can easily prove that in this way, given that second question is given that like this: f of x as f maps r to 0 to infinity, and defined as f of x is equal to 2 power of x. So first of all you have to prove that it is an injection or not. So we can easily write as injection function means f maps a to b. We have to write the definition. Okay, f of x1 is equal to f of x2, whether x1 x2 is belongs to a, then we can write as x1 is equal to x2. Here we can change them like this: f maps r to 0 infinity, and x1 or x2 is belongs to r, then f of x1 is equal to f of x2, that is, then we can write as directly x1 is equal to x2. Then we have to prove them. Okay, f of x is given as 2 power of x, then 2 power of x1 is equal to 2 power of x2. Then bases are equal, then directly we can write as, yes, bases are equal, then the exponents also equal, then we can write as x1 is equal to x2. Hence you prove that f is a injection function or 1 function. Okay, this is condition 1. Let's take for the, we have to write the prove that as f of x is equal to y in the second hand, then 2 power of x is equal to y, then x is equal to, we can write as log y base 2 in this way. Okay, then f of x is equal to, we can write as 2 power of log y base 2. But we know the formula for this, we can directly as y, then f of x is equal to y, so it is condition 2. So we can write as f is a surjection function. From 1 and 2 we can directly write as f is a bijection function. These are proofs for this. Okay, very simple, and we have to just use our spontaneity, that's all. Okay, let's move for the third bit. I think viewers can understand it, and if anyone got any doubt, please any doubts, put a message in comment box and I will definitely support you. And let's move for the third one. Okay, let's move for the third one. The third one given as like this. Third one given as f maps 0 to 0 infinity to r, and f of x is equal to log x base e. Then find show that they are the bijection or not. Okay, let's find out the first of all. We know that in case we have to prove that a given function is whether injection or not. Okay, let's go for that. Yes, we know that if f maps 0 to infinity to r, and x1 and x2 is belongs to r, then f of x1 is equal to f of x2, then we can write as x1 is equal to x2. Here is the function. Then f of x is equal to log x e base a, then we have to write f of x1 is equal to f of x2. We have to prove that. Then log x1 base e is equal to log x2. Very simple, it is x2. Then log by applying log both sides, inverse log, we can get as x1 is equal to x2. This is the one. So we can prove that as it is given as a injection function. It is a simple injection. Now we have to prove that given that it is a surjection or not. Then we have to condition. So we know that f of x is equal to y. We have to write like this. Then we can write as y is equal to log x base e. So in the log basics we read out, we know that we can directly write as e is equal to e power of y. Sorry, x is equal to e power of y. Then log x is equal to, f of x is equal to, small confusion. Then f of x is equal to, we know that log, okay, log x base e. Then write the answer e base e power of y. Then we can write as y into log e base e. Then is equal to y into 1, that is equal to y. Okay, here we prove that f of x is equal to y. Then f is a surjection. Okay, that is a onto function. Onto function or surjection function. From 1 and 2 we can consider f is a bijection. Bijection function. Okay, in this way we can prove that easily. Let's move for the another one. There is simple technique there. While showing that is injection, we will take as f of x1 and f of x2, and while showing in the surjection we will take as f of x is equal to y. That's simple. Okay, you can do the fourth one also. I will explain only fifth one and sixth one. It is a small changes there, and you can answer the fifth one also. Is easy one. Yes, you can answer easily the fifth one also. Now I am answering only sixth one. I am answering. So in this way you can easily answer the fifth one also. So I will explain the sixth one. Sixth one is something different there. So sixth one, given that f maps R to R, defined as f of x is equal to x square. Okay, let's take further f maps R to R. Okay, f of x is defined as x square for every x1 and x2 belongs to R. Then we have to prove that f of x1 is equal to f of x2, that's x1 is equal to x2. Okay, let's write the function here. That means x1 square is equal to x2 square. As while applying both sides square root, we will get as x1 is equal to that means both sides we will get as a plus or minus x2. That means sometimes we will get as x1 is equal to minus x2, and sometimes we will get as plus x2. Thus we cannot write x1 is equal to x2 in all cases. Then we know that x1 is not equal to x2. Then f is not a injection function. Okay, in this way we can prove that is not a injection function. Okay, so in one case we got it is not a injection function, then automatically we know that yes, we can easily consider that it's not also surjection also. Okay, let's go for that, whether it is surjection or not we will go for that. And f of x is equal to, we have to write, then x square is equal to, we can write as, yes, x square is equal to y, then x is equal to square root of y. Okay, let's put the values. Okay, yes, so let's go further. Then we can write as f of x is equal to x square, then f of x is equal to, we can write as, so f of but here we know that only one thing we know that there is no image for the x in the given given function. Simply we can write it, there is no image, there is no image for the given number. So then we can directly write as f also f not a surjection. Okay, directly we can state here there is no image for the given function. Okay, then we can write as directly it is not a surjection. Then if it is not a injection or not a surjection, then we can write as directly it is not a bijection also. This is about the question number 6th one. Let's go for the third one. Okay, these are the important questions for the 5 marks questions in IPE. Okay, let's go for the next one. The third question defined as G is a set of 1 1 2 3 3 5 and 4 7. Okay, so here and A is a set of A defined that 1 2 3 4 and B is a set of defined as 1 3 5 7. Then g of x is equal to ax plus b as defined as g of x is equal to ax plus b. Then find the ab's, then find the ab values. Okay, now we have to prove you have to find the ab values. Okay, let's go further. Solution. Here from the function value we know that g of 1 is equal to 1, and second one g of 2 is equal to 3, and g of 3 is equal to 5, and g of 4 is equal to 7. He given that in the function Cartesian product. And then we know that g of x is equal to ax plus b. Then let's go for the x. Then we can write as a of 1 plus b is equal to 1. That means a plus b is equal to 1 from the first one. And let's go for the second one. So g of x is equal to ax plus b. Here we have to take the 2 value. Then a into 2 plus b is equal to, the value will be, that means the image will be 3. Then 2a plus b is equal to 3. These two. Let's consider equation 1 and equation 2. We can write directly. Let us minus 2 minus, let's do 2 minus 1. We can write as a 2a plus b is equal to 3 and a plus b is equal to 1 minus, we can cancel the easily minus 1 plus 1, and 2a minus 1 is equal to 1, that means a, and 3 minus 1 is equal to 2. Then a is equal to 2, but in the first equation we know that a plus b is equal to 1, then 2 plus b is equal to 1, then b is equal to 1 minus 2, that is equal to minus 1. Here finally we got as a is equal to 2 and b is equal to minus 1. Here the answer. Okay, in this way we can easily find the answers. Okay, this is about the question number 3. And somehow most important questions are 4th one and 5th one. Sometimes they are the very tough one to answer in a limited time, whether we forget the process. So I'm going for the answer the 4th one. So stay calm to understand question. Why? Because it is a little bit hard. Okay, the most important question and a little bit hard. Let's go for that. Okay, the question given that f maps R to R and f defined as f of x is equal to 3 power of x plus 3 power of minus x by 2. Then find the f of x plus y plus f of show that f of x minus y is equal to 2 of f of x into f of y. So first of all we have to individually find the f of x plus y and f of x minus y, and then we have to add both them. Let's find out f of x is equal to, we know that 3 power of x plus 3 power of minus x by 2. Then f of x plus y is equal to 3 power of x plus y plus 3 power of minus of x plus y by 2. Okay, let's find the values. Then we can write as let's expand them. Then we will get as 3 power of x into 3 power of y, here minus, plus 3 power of minus x into 3 power of minus y whole by 2. This is for the x plus y. Now go for the x minus y. Then f of x minus y we can write as 3 power of x minus y plus 3 power of minus of x minus y whole by 2. We can write as 3 power of x into 3 power of minus y plus 3 power of minus x into 3 power of y. Why? Because minus of minus is equal to plus by 2. This is 2. But now we have to add both of them here. Then f of x plus y plus f of x minus y. Then we will calculate as 3 power of x into 3 power of y plus 3 power of minus x into 3 power of minus y. So denominators are equal, so directly we can add as them 3 power of x into 3 power of minus y plus 3 power of minus x into 3 power of y whole by 2. Okay, denominators are equal. Then let's factorization them. Let them factorize. Let's common thing. Let's take 3 power of x first of all. So let's consider both. Yes, divide them as a 3 power. Just once again. Yes, 3 power of x into 3 power of y plus 3 power of x into 3 power of minus y. I change the places of both of them, and plus 3 power of minus x into 3 power of minus y plus 3 power of minus x into 3 power of y. Okay, whole by 2. Okay, now I will take common from them here. So 3 power of x, and let's take common as, then we will get as 3 power of y plus 3 power of minus y. Here also let's take the 3 power of minus x, then we will get as a 3 power of minus y plus 3 power of y. Okay, then whole by 2. Then we can easily write as 3 power of x plus 3 power of minus x into 3 power of y. Okay, 3 power of y. Yes, 3 power of y plus 3 power of minus y. Okay, whole by 2. Okay, we got it there. Okay, then let's take them, just adjust them like that. I can write as, yes, 2 by 4. Let's take the common as 2 by 4, and we can write as 3 power of x plus 3 power of minus x of 3 power of y plus 3 power of minus y. Okay, that means we can simplify it, and we will get as also once again we will got as 1 by 2. Okay, then now I can write as the denominator of 4 as like this, as 3 power of minus x by 2 into 3 power of y plus 3 power of minus y by 2. Here we have to write 1 by 2. Sorry, 2. That means denominator 4 is taken inside, and we can write as here 2. Okay. Finally we got. Let's go for the question. Is there a question given as f of x is equal to 3 power of x plus 3 power of minus x whole by 2. Okay. Now go for the final step. The final step we got that. Okay, 2 of 3 of x plus 3 of by 2 into 3 power of y plus 3 power of minus 1 by 2. Then we can write as 2 of f of x here, and here f of y. Okay, thus we got as 2 into f of x into 2 f of y. That's the answer. In this way we can easily prove them. Okay, this is the proof for that. Okay, now the question given as f of finally we can write as, therefore f of x plus y plus f of x minus y is equal to 2 into f of x into f of y. That's the answer. In this way we can easily prove that. And let's go for the next question. Okay, let's go for the next question. The next question is given that as f maps R to R as defined as f of x is equal to 4 power of x by 4 power of x plus 2. Then prove that f of 1 minus x is equal to 1 minus f of x, and find the values of f of 1 by 4 plus 2 of f of 1 by 2 plus f of 3 by 4. Okay, I will do the only proof, and I hope you will be practice the answer. Okay, let's go for the next question. I will give the only proof, and I hope all of you will answer the question. Let's go for the fifth question. Let's go for the fifth question. Fifth question is given that as f maps R to R and define that f of x is equal to 4 power of x by 4 power of x by 4 power of x plus 2. Then show that f of 1 minus x is equal to 1 minus f of x. I will do the only proof, and I hope you will answer the remaining values, that is f of 1 by 4 plus 2 of here. You have to prove that. Okay, I will show the only proof here also. So f of x is equal to, given that as 4 power of x by 4 power of x plus 2. Then f of 1 minus x is equal to, we can write as 4 power of 1 minus x by 4 power of 1 minus x plus 2. Okay, let's simplify that. Let's do first simplification here. Yes, go for that. We can write as 4 into 4 power of minus x whole by 4 into 4 power of minus x plus 2. Then 4 power of minus x we can write as 4 by 4 power of x whole by 4 by 4 power of x plus 2. Okay, that means we know that 1 by a is equal to a power of minus 1. In this way we change that 4 power of minus x we write in the denominator, and then we can LCM the denominator. We can get as 4 plus 2 into 4 power of x by 4 power of x. Then cancel the denominators. Okay, we will get as 4 by 4 plus 2 into 4 power of x. Here we got. Okay, now now okay, so now we have to write as like this: 4 plus 2 into 4 power of x minus 2 into 4 power of x. By adding and subtracting, the value should not be changed. Yes, in this way we write as 2 times here, just to consider here. So we write here by adding and subtracting, so the value never changes like this. Then we can write as 4 plus, we will divide them into 4 plus 2 into 4 power of x by 4 plus 2 into 4 power of x, and minus, we can write as 2 into 4 power of x by 4 plus 2 into 4 power of x. By simplifying this, we can get that we will get 1 minus, we can write as here let take the common 2. Let take common 2, we can write as 4 power of x by 2 into 4 power of x plus 2. Now we can easily cancel common, then we will get as 1 minus 4 power of x by 4 power of x plus 2. Then we can directly write as 1 minus f of x. That's the answer for the given. So okay, that's the fifth question is also answered. Okay, it's a lengthy process, but you can definitely answer easily. I hope you understand. and there is the remaining part in the question is to find the values. Okay, find the values of the given. Okay, you have to find them. Okay, let's go for the fifth question. Let's go for this I think the sixth question. I hope the remaining part will you have to do. That is very simple. You have to substitute the values in the given function, then you can easily answer them. Okay, so in the remaining part there is another part is given, so you have to just find the answer, find the values. You have to find the values. Okay, then I will go for the sixth one. And I hope you will try. It is a simple question. I think you will try for that. And I will go for the seventh one. Okay, I will go for directly for the seventh one, and it is very easy. You have to find easily. Yes, you can easily find them. That means f of minus 1 is equal to 0 and f of 1 is equal to 2. Then you handwrite as a of minus 1 plus b is equal to 0 and a plus b is equal to 0. Then easily you have find the ab values here in the sixth question. And I am going for the seventh one. Okay, I am going for the seventh one. Seventh question is given as f of x is equal to cos log x. Then find the f of 1 by x into f of 1 by y in minus of into f of x by y plus f of xy is equal to 0. We have to prove that is equal to 0. I am going for the last question. By this question the first exercise will be complete. Okay, I think everyone watching, I do understand. I think everybody understand the easy way. Yes, let's go for the answer. We know that first of all we have to find the each and every value individually, then finally we will add all at once. Okay, first for the f of 1 by x, and f of 1 by x is equal to cos of log 1 by x. Okay, cos 1 by log. We know that log 1 by x is equal to, we can write as cos a by b is equal to, log a by b is equal to, we can write as directly cos of that means log 1 minus log x. Log 1 minus log x. Okay, we know that cos a by b, log a by b is equal to log a minus log b. Then log 1 is equal to, we know that 0. Log 1 is equal to 0. Then we write as the 0 minus log x, that is equal to cos, it is not cog, it is cos minus log x. Okay, that means minus cos of log x. That's the for the first one. Okay, next one we can write yes, here is a simple, yes, small correction here. Cos minus log x is equal to, we can write as cos log x. Okay, this is the first one. And let's go for the second one, f of 1 by y. So in this way we can directly write cos 1 by x is equal to, f of 1 by x is equal to, we got as cos log x. Then f of 1 by y, as the process we will get as a cos of log y. Directly we can write here. And let's go for the f of x by y. F of x by y, then we can write as cos of log x by y is equal to, there's a small correction, the s is not coming from my hand today. Okay, cos, okay, we can write as cos of log x minus log y. Okay, then we will write as yes, let's go for the fx. We can write as cos log x minus log y. And go for the f of xy, we can write as cos of log xy, we can write as cos of log x plus log y. Here is the 4 values. So first one, second one, third one and fourth one. Let's go for the question now. Let's go for the question 1. Question given as f of 1 by x plus f of 1 by y minus of 1 by 2 of f of x by y plus f of xy. Okay, we have to put that. Then first of all, you have to substitute all values here. First one is the f of 1 by x. We can write as, yes, there is no into, it is multiply. Then it is right, and we can write as cos log x, cos of log x into cos of log y minus 1 by 2. Here we can write as cos, in the brackets we got is let us see this, we got as like this. We can write as cos log x minus log y plus cos log x plus log y. Every time the negative will be changed into positive. Then cos log x, just a side, just a cos log x into cos log y minus of 1 by 2. Can write as inside, we can write as cos, yes, we can write as 2 cos log x into cos log y. Okay, as a trigonometric formula we can simplify them. Then we can write as cos log x and cos log y minus 1 by 2 into cos of log x into cos of log y. And finally we simplify into, then we will get as cos of log x into cos of log y minus cos of log x and cos of log y. Okay, finally we can cancel them, we will get as 0. So finally we got the RHS, that means RHS. Thus we can prove that given LHS is equal to RHS. Okay, this is the for the all questions I explained here. If there is any grammatical errors and if there is writing errors, please consider them, and I hope everybody will understand all the questions, and I hope you will understand, and please give your feedback. And thank you again very much. This is about the 1A exercise, and in our next class we will go for the composite functions and inverse functions in our class, and after that we will do for the 1B also. Okay, 1B exercise also I will explain each and every question. Thank you guys, thank you very much for watching. Thank you very much, and I hope everyone give the feedback, and whether it is positive or negative, please give your comments. And I hope if there is any grammatical errors and writing errors, please consider, and I hope do you got the correct answers here. Thank you guys, thank you very much, bye bye.